Hello everyone, good morning, good afternoon, good evening. Today we are going to learn fabric path traffic flow. So let's see, how the packet flow in fabric path happens. So in order to send the traffic in a fabric path domain, once network administrator configures the fabric path connectivity, the switch table and the multi-destination tree and the MAC tables are already created. Now, there are two types of tables, traffic that are available, and for different type of traffic, following tables are used. So for the broadcast, a non-unicast and multicast traffic, multi-destination tree and MAC table is used. And for the unicast data, that is for the data traffic, switch table and MAC table is used. Now let's see how the multicast tree is created. So for the ARP request or broadcast, a known unicast, that is for the ARP reply, which is only for the fabric path technology, and for the multicast, multi-destination trees are created. Now in the fabric path domain, two multi-destination trees are created for which two route switch has to be defined. Route switch can be defined or elected by the following method. So route priority, right? Its value is between 0 to 255. Default is 64. Second is system ID, that is MAC address of switch. Third is switch ID, which the DRAP protocol assigns, right? So in this domain, one switch will become a route for multi-destination tree 1 by using these values. So these values will be higher side will be taken, right? So higher the route priority, route will be the those which will have a higher route priority or a system ID will be elected for a route switch for a multi-destination tree 1. Okay, now once the switch becomes the route for multi-destination tree 1, then a second route switch will be negotiated by using these values among other switches. So by this we will have a two route switches, one route switch for multi-destination tree 1 and second route switch for multi-destination tree 2, right? So by the help of route priority command, route priority is the command, right, which is used to configure the route priority into the fabric path domain. So let's see, understand, how this happens. So let's suppose I have, this is my fabric path topology, right? So as per rule, we have to create a two tree 1 and tree 2. So for tree 1, one will be my route, one switch, and for tree 2, another switch will be my route switch. So roots, so first the tree 1 will be created. For that, each switch will negotiate or share its route priority, system ID, switch ID, and based on the value, let's suppose my route becomes switch 100. So this is my tree 1 and this is my tree 2. So at first, tree 1 will be created, and after negotiating the route priority or system ID or switch ID, switch 100 becomes the route for a tree 1. Now from the route, the shortest path to reach all the switches will be created, and this forms a tree 1, right? Once the tree 1 is created, now it will be the turn of tree 2. After creating a tree 1, all the remaining switch will participate for negotiation of route bridge. Now let's suppose in that case switch 400 wins and it becomes the route for a tree 2. Now switch 400 will form a tree that contains the shortest path to reach to each and every switches. So that is why tree 1 and tree 2 are created. Ideally, In every case, tree 1 will be used, tree 2 will be used for backup purpose if the root of tree 1 is not available for any certain reason, right? Now let's see, what is the fabric path conversational MAC address learning. So let's suppose, if I talk about the regular MAC address learning scenario, what happens? So I have two switches, right? I have a host A connected here. This is my trunk port, anything, right? This is my host B connected over. Now when a host A sends a traffic, host A MAC address is learned here. When this packet reaches here, MAC address is learned here, right? So each switch upon receiving the layer 2 frame learns the MAC address of the source, right? Now, so what happens? This makes the MAC address table larger and larger in case of if we have a traditional data center, right? But in the case of conversational MAC address learning, what happens? So let's suppose if this is my switch 1, this is my switch 2, this is switch A. Sorry, this is host A and host B. This is my trunk port. Now, when a host A sends a packet to host B, A will be learned here. Now, when a switch 1 sends a packet to switch 2, the 2 will not learn the MAC address A, right? Rather, it will forward the packet to switch B, right? Let's suppose, host A sends the ARP request, right? So ARP request reaches to switch A, source MAC address of host A will be learned. Now this is a broadcast, so switch 1 will forward the packet to switch 2. Switch 2 will not learn a MAC address. It will forward the broadcast to switch B, host B. Now host B replies to ARP reply, provides the ARP reply, switch 2. Because switch 2 has not learned the a MAC address, it will send a unknown unicast, right? So it will send an unknown unicast, which is also a type of multicast. It is also type of broadcast traffic. So that will be flooded and it will be reached to switch 1. Now, because the ARP reply is a response of ARP request, so it completes one bidirectional conversation. Bidirectional conversation, right? Now here the switch 1 will learn the MAC address B and then it forwards the ARP reply to switch A. So in the conversational MAC address learning, when a traffic MAC address is only learned which has a bidirectional communication completed, right? So in the MAC table, when the MAC table is populated in the fabric path, there are two types of entry. One is the local entry, that is any MAC addresses of the host which is directly connected to the switch. So in that case, host MAC A and MAC B are the local one because they are locally connected to switch 1 and switch 2. But remote MAC address in the switch 1, B will act or marked or tagged as a remote MAC address. Why? Because B MAC address is originally connected on a different fabric path enabled switch and is learned after bidirectional communication has been established. So this is the conversational MAC address learning. When one conversation is completed, the MAC address table is learned. Now when A will send a data packet to switch B, switch 2, right? In that case, one bidirectional communication is completed. Now switch 2 will learn the MAC address A here. Okay, so switch learns the remote MAC address only if the remote device is having a bidirectional conversation with the locally connected device. So this is called as a conversational MAC address learning. So this will be used in the traffic flow. We will see it. Now let's suppose we will see the fabric path packet forwarding, how it happens. So once the we have enabled the fabric path domain, we have configured the fabric path domain, what will happen? Switch table, right? Multi-destination tree, is already created, right? So this is my multi-destination tree 1, and this is my multi-destination tree 2. Okay, now let's suppose host A want to talk to host B, but host A doesn't have the the MAC address of B, so it will create a ARP request. So ARP request is sent from host A to switch 10. So this is my ARP request, this is my source MAC address, which is host A, and destination MAC address is FFFFF. Now once the ARP request goes to switch ID 10, because what the switch 10 will keep the MAC address, it will launch the MAC address on the Ethernet 1x5, and because this is a broadcast packet, it will see the it will consult the multi-destination tree for switch 10. Now it will select a by default multi-destination tree 1, and it will see that to which interface I can send this broadcast. So it will have ETH 1x1, 1x2, 1x3, 1x4. So it will send all this packet to all this port. It will broadcast it, right? Before broadcasting it, because it is your fabric path domain, so it will encapsulate it to fabric path header. So this is my original Ethernet frame, right? Now over it, what happens? My ETH frame is encapsulated to outer source address and outer destination address, if you remember, and each outer destination address or source address has a SSID, sub-switch ID, and a port ID. So SSID, sub-switch ID, and a port ID. Now here, what is my source? Because my traffic is going from switch 10, so my source ID will be switch ID 10. Sub-switch ID will be 0 because there is no VPC port channel, right? Likewise, in the outer destination, because this is a broadcast, so under sub-switch ID it will be FFFF, right? It will be 0. So this is my source, because the switch 10 is encapsulating a packet and is forwarding to the fabric path domain. So this is my source switch ID, this is my destination, and this broadcast packet is sent over the multi-destination tree interfaces. So once this switch 100, let's suppose it reaches to the switch 100, because this packet received, and on the destination header it is FFF, the switch 100 will see that, okay, this is a broadcast packet, so I have to check my multi-destination tree. Again, it will look for multi-destination tree 1, and it will look for the interfaces. ETH 1x1, it has already received it, so ETH 1x2 and ETH 1x3, it will send it without any encapsulation. It will forward as it is. Now the packet reaches here, the packet reaches here. Now the switch, once the the broadcast packet reaches to the switch 20, switch 20 will again see its tree, right? So let's suppose switch 20 will see that, okay, it will consult a tree. And in the tree 1, you can see that it has only one leg, right? And it doesn't have any host, so that packet will be discarded. Now the broadcast fabric path frame reaches to switch 30. Here it will look for its own multi-destination tree, switch 10. It will check the interfaces. So see here, this is my switch 30, right? I have received from switch 100, so I will not forward it, but I have a connectivity to switch 200, switch 300, and switch 400. So from here it will broadcast it to other switches also. But it has the host, right, connected here. So what it will do, it will decapsulate the fabric path frame and forwards the original Ethernet frame to host B. Here after decapsulating, it is not going to learn any MAC address of A because of the conversational MAC address learning rule. Bidirectional communication has not been established. It's only a one-way path. Okay. Now, once the ARP request is sent to, the host B, now the host B will reply it, ARP reply it. So let's see how the ARP unicast ARP response happens. Again, the host B will send a ARP reply with payload A, source MAC address is B, destination MAC address is A. Why? Because it has learned the host A MAC address. Now, once the packet reaches to switch 30, right, it will add the MAC address B that is connected to ETH 1/5. Now, it will also check where the destination A is connected, but in its MAC address table, MAC A is not learned. So it will treat this packet as a unicast ARP response, and then it will decide to forward it to all interfaces. So then in that case, it will check its multi-destination tree. Again, it will take a preference for multi-destination tree 1. It will check the interfaces, then encapsulate it to the fabric path header. Again, the source is switch 30, subswitch ID will be 0. Here the destination MAC address will be reserve multicache address. It will use, and this is of 01.0F:0C:01:C0, right? So due to space constraint, I have written multicache address, but this will be your reserve multicache address in the destination address, and FT tag will be 1. Now this packet will be forwarded as per switch 30 tree 1 interfaces. It will be sent here, it will be sent here, it will be sent here, it will be sent here. Now once the packet reaches to switch 100, because it is your unknown unicast packet, the switch 100 will check its tree 1. It will check what is the interface that are connected towards my tree 1, right? And then in that case, it will forward it to these interfaces. Okay. Now once the packet reaches to switch 10, right, because it is a broadcast, it will also check for its tree, and tree 1. In this tree 1, it will see that, okay, I have only one interfaces connected, right? So in that case, but I also have a host A connected to it. Now, upon receipt of a unicast ARP, switch B, the host switch, the switch 10 will learn the MAC address of B pointing towards this switch ID. So in the MAC address of switch 10, host B MAC address is learned, and which points to 30.0.2 as a remote. So this indicates that host B is connected to the switch ID 30, right? And it will be tagged as a remote, because this packet is bidirectional. This packet has this flow has completed the bidirectional, because ARP request has been sent, and for that response ARP reply has been sent. So one bidirectional communication has been achieved. So as per conversational MAC address learning, host B MAC address is learned on a switch 10, and then the packet is decapsulated and it is forwarded to the host A. So this is how unknown unicast ARP response is progressed. Now let's see how unicast data is completed. Now host A has the MAC address of host B. It will create a Ethernet frame. It will send it here. Now because the switch S10 will check its MAC address table. It will see that, okay, B is connected on 30.0.2, which is switch ID 30. So in that case, because it is not a broadcast, it is not unknown unicast, it is not a multicast, so it will not consult the multi-destination tree. Rather, it will check the switch table. Now it will see that, okay, where my switch 30 is connected. So it will see that, okay, switch 30 is reachable via ETH 1 by 2, 1 by 1, 1 by 2, 1 by 3, 1 by 4. So I have a 4 interfaces through which I can reach to switch ID 30. Now in that case, the Ethernet frame will be encapsulated with the fabric path header, where source ID will be switch 10 and destination address will be switch 30. Now I have a 4 path, equal cost path available. So hash will be done. After hashing done, let's suppose ETH 1 by 1 is chosen, right? So the switch 10 will send a traffic to switch 100. Switch 100 will see that, okay, where my switch 30 is connected. It will see that, okay, it is connected to 1 by 3. So there is a mistake in diagram, right? Now the packet is forwarded to switch 30. Now once the packet is reaches here, before decapsulating it, I mean, it will decapsulate it, and side by side, before it will decapsulate the packet, and side by side also it will learn the MAC address A, which is pointing to switch ID 10, right? And then this packet, decapsulated packet, will be forwarded to host B. Okay, so just make a correction. This is not switch 300, it is switch 30. Okay, so this is how your unicast data is progressed. So thank you for watching Fabric Path Traffic Flow. Thank you very much. Take care. Bye bye.